Hello, my name is John Meter from Northern Stars Planetarium, and today I'd like to share with you some great information about the planets. But first, I want to share with you something I found at a yard sale. You see this carpet behind me? Isn't it cool? I love planets, as some of you already know, and when I saw this at a yard sale, I had to have it because I just like planets so much. It's colorful and it's got all the planets on it, but it does have its problems, you know. Think about it. Look at Jupiter. Look how big they made Jupiter. Now we know Jupiter's a big planet, but look how big it is compared to the Sun. Is Jupiter really bigger than the Sun? No, the Sun's way bigger than Jupiter. Look how big Earth is compared to the Sun, or even Jupiter for that matter. They've got the sizes all wrong. And are the planets really all that close together? No, they're really spread out. So I'd like to help you today by understanding how big and small the planets are compared to each other, and a little bit of the distance about how far apart they all are. So let's start with something we're familiar with, the Earth. I've made a model of the Earth to begin with. So here is our Earth. And the Earth turns. It rotates. To spin all the way around once, to rotate one time, takes 24 hours or one day. So the Earth is spinning once every single day. And as we spin around, when we're on the side that's facing the sun, we call that daytime. And when we spin around so we're not facing the sun, then that's nighttime. All the planets do that. But the Earth has a second motion. You know where else it goes? It revolves around the sun. Rotating is spinning like a top on an axis, and revolving is when you go around something outside yourself. And the Earth goes around the sun. So we have the sun over here, and the Earth slowly over time goes all the way around behind the backside, then over on this side, then back around to make a whole orbit. That takes a year, 365 days. That means by the time the Earth goes all the way around the sun one time, the Earth is spun around on its axis 365 times. It's amazing we're not all really dizzy, isn't it? But we're busy moving in a couple different ways. But that's not all that moves. Our nearest neighbor goes around us. What's that called? The moon. Here is the size of the moon. You can see it's a little bit smaller than the Earth, isn't it? If you put the moon on the Earth so that one edge was in Maine, the other edge would be, well, probably the other side of Colorado or Utah, somewhere like that. So it's pretty big, but quite a bit smaller than the Earth. And the moon goes around the Earth. I can't make it go around because my arm's in the way. I could tip it around and go around like this, couldn't I? So it goes around like this. To go all the way around the Earth one time takes a month. That's where the length of time of a month came from, is the orbit of the moon. Now, how far away is the moon? We put them this far to make our diagram because it works well. You can see them close together this way. But they're not really that close together. We got to spread them apart. So, what do you think? Is that better? Well, it's better, but it's still way too close. You know what? The distance from the Earth to the moon would be like stacking 30 Earths on top of each other between the Earth and the moon. That's quite a long ways. Turns out, if I want to show you what that's like, if I took the Earth and placed it on one side of our carpet right over here, the moon would be on the other side, right over here. So they're pretty far apart. No wonder it takes the moon a whole month to go around the Earth. It's a long journey. So this is our nearest neighbor. It's probably not our most famous object in the sky, though. The most famous object, of course, is the sun. Have you ever noticed that the sun and the moon look like they're the same size when you go outdoors? Well, they're not really the same size. Which one's bigger? Yeah, the sun's way bigger. It's just a lot further away, isn't it? Would you like to see how big the sun would be? Well, I can't do that one for you. The reason I can't do that one for you is because at this scale, with the Earth this size and the moon this size, the sun would be bigger around than your house. It'd be over 20 feet in diameter. I don't have a model that big. So if we want to make a model that'll fit here in the room that I can share with you, I need to shrink the Earth down to a point where it shrinks the sun down so it'd fit. We have to scale down, in other words. So we're going to do a little magic trick. Make the Earth disappear at this scale and make it reappear at this scale. Now we have what looks like a little tiny Earth, don't we? And that would make the moon very small, like the size of a grain of sand. But it makes it so I can bring the sun in the room. You want to see how big the sun would be if the Earth were this big? Here is our sun compared to the Earth. Wow, it's a lot bigger, isn't it? If the sun were hollow like a bubblegum machine and you wanted to fill it up with Earths instead of bubblegum, you could put 1,200,000 Earths inside of it. So it's really, really big. It's bigger than all the planets put together. It's over 1,000 times bigger than Jupiter, so it's huge. Well, I'm not going to hold the sun because it's big and it's hard to hold, but I did sit it down right here beside me so we can keep an idea of how big it is. Shall we look at the other planets? So we'll compare them to the Earth and the sun here. Let's just head out from the sun. The first planet is Mercury. Look how tiny Mercury is compared to the Earth. It's about the same size as the moon, just a little tiny bit bigger, but not much. Compared to the sun though, wow, it is really, really tiny, isn't it? We move out further, the next planet is kind of clever because what do you notice? It's about the same size as the Earth, isn't it? This is called Venus. Venus and Earth are almost exactly the same size. Earth's a hair bigger if you measure them carefully, but if you just look at them you couldn't really tell because they're so close to the same. If we pass Earth, the next planet is smaller, and that's the red planet Mars. Mars is a smaller planet, though it's bigger than Mercury, and it's probably the next planet, or the first planet we'll visit for astronauts to go and visit after visiting the moon. And if you look on top, you might just see a little white spot there. That's ice at the North Pole. And if you look at the bottom, there's the ice cap there too. Like we have ice on the North and South Pole of the Earth, so does Mars. Mars, being farther from the sun, is going to be cooler than the Earth, and the air is poisonous, so it's not going to be easy to live there, but people will probably go visit there sometime, hopefully soon. Compare Mars to the sun, it's pretty tiny. We should talk about something big. Leave Mars behind, the next planet is bigger. And that, of course, is Jupiter. Look how big Jupiter is compared to the Earth. It's very different than the planets we've visited so far. The planets Mercury and Venus and Earth and Mars have ground. You can land on them, you can walk around on them. You might not want to, but they're solid. Jupiter doesn't have ground. It's clouds and gases, and the winds blow in these bands. And they're blowing over 100 miles an hour. And that creates storms like this famous red spot. That's a giant hurricane, bigger than the Earth. It's been blowing around on Jupiter for a couple hundred years. But when we think about big, this may be the biggest planet, but compared to our neighbor the sun here, our star, it is still pretty tiny, isn't it? Planets don't measure up to stars very well. The next planet is almost as big as Jupiter, but a little bit smaller, and that's Saturn, with its beautiful rings. Saturn is the second biggest planet. The rings are made of ice, mostly water ice. And the width of them is wider than the Earth, as you can see here. But thickness-wise, from top to bottom, measured this way, if you had a soccer field or a football field at your school, and you could tip Saturn up sideways and drop the rings down on your field, they'd fit between the goalposts. Thickness-wise, it's thinner than the length of a football field or a soccer field. But it'd shoot thousands of miles up in the sky, because this is thousands of miles wide. So Saturn's kind of an interesting giant planet with those amazing rings. The next one is Uranus. This one's bigger than the Earth, but not nearly as big as Jupiter or Saturn, compared to the Sun, and the way people usually envision the Earth, isn't it? It's actually quite a bit bigger than the Earth. The interesting thing about this is the North Pole's not on top like the other planets. It's on the side right here. And the South Pole's over on this side over here. So when it rotates, it actually rotates this way, whereas the other ones spin on their axis like this. So its axis is kind of sideways. It's the only sideways planet. Now, the final planet is often referred to as the twin of Uranus, and that's Neptune. They are about the same size, aren't they? And they both have a bluish color, but Neptune's not tipped sideways. Its North Pole's right on top, so it spins around like the Earth. So we see the planets are all different sizes. We have gas giants that are larger, and terrestrial planets, that means they have ground, like Mercury, Venus, Earth, and Mars. Those are the planets. But there are more objects beyond Neptune. There are a lot of icy objects out there. The most famous one is Pluto. And I'd like to show you Pluto because it's pretty tiny. It may be small, but it's very famous. Here is Pluto. Look how small it is. It's smaller than our moon. And we called it a planet for many, many years, but we found there are lots of other objects out there about the same size as Pluto. And some of them are round, just like Pluto's round, like a planet. So we call them dwarf planets. Well, thank you for joining me today, and I hope you get outside and find some of those planets and contemplate how far away things really are in space. It's always farther than you think. Keep looking up.